Hi everyone, my name is Wim Vancauwenberghe. I'm director at BIMAS, the Belgian Maintenance Society, and I welcome you at this Asset Performance podcast. We're going to talk about industrial maintenance in transition today, and I have an interesting panel with me. First of all, Mr. Kourosh Bahrami, welcome.
Hello, Wim.
Yes, you're working at Henkel Adhesive Technologies. What kind of company is that?
Well, Henkel overall is a 20 billion company with 50,000 employees. Half of it is Henkel Adhesive Technologies. We are the leader in the space of adhesives, coatings, and sealants. But very specifically for the community of this podcast, I think we are one of the leaders in MRO space, helping to reduce unplanned downtime, increase safety, and all the things that are important to MRO workers.
Yes, so and what is exactly your role at the organization?
Within Henkel, I'm leading the business that is specifically taking care of the MRO space. We're talking about worth $1 billion, north of $1 billion business and 2,500 people with 1,000 customer-facing colleagues that help the MRO workers in the different plants of the world.
Yes, and we are going to address digitization in that world also. And you're joined with a colleague, Michael Honné. Hello, Michael.
Hello.
Welcome also at the podcast. So maybe you can also explain a little bit your role at Henkel Adhesive Technologies.
Yeah, thank you for having me, and happy to briefly introduce myself. I am within the organization that Kourosh just mentioned, responsible for Loctite Pulse, which is actually exactly in that field of maintenance, repair, and overhaul, so MRO, but different to our previous offering, which was mainly about chemical solutions, so a lot of bonding solutions, a lot of coating, functional coating solutions in particular, but also sealing solutions. Now it is about digital solutions in that field. So we are extending our current offering by digital solutions, and we'll talk about that more in today's podcast for sure.
Yeah, well, sure. And we are joined also by Mr. Peter Gijbels of Endress and Hauser. So maybe also for the ones that people that are listening and don't know very well Endress and Hauser, maybe Peter, you can explain a little bit what are the activities.
Yes, Wim, no problem. Hello, everybody. Nice to be in this nice group of very interesting people. So, Endress and Hauser, I think most of the people that know the name know that our bread and butter is instrumentation. So, meaning flow measurements, temperature measurement, analysis, pressure, and stuff. So, we have a lot of instrument devices. However, we do also have a very comprehensive set of services and solutions. And with these services and solutions, like Kourosh already mentioned, we are helping asset owners to reach their asset management goals. So we are certainly also here to help asset owners how to improve their maintenance processes and how to do asset management better. And of course, instruments are an excellent source of data that we want to provide, and in digitalization, data is of course key.
Yeah, okay. And what are your responsibilities within Endress and Hauser?
Yes, recently I joined the organization in Belgium, where I'm actually the optimization and consultancy manager, and in the same time I'm head of solutions and services in Belgium. And I still have a link towards the corporate world of Endress and Hauser, where I'm supporting in many work groups and teams the development of our services and solutions.
Okay, so you're really at the forefront of this, applying this digitization. Interesting to have you all here at this conversation. Digitization is really transforming our industries nowadays. So how do you see digitization impacting the landscape of industrial maintenance, Kourosh?
Well, first of all, we see digitalization drastically changing the environment when it comes to our 500,000 customers, but also if we take our own plants, we have 140 around the globe. We see massive change. It is massive change, first of all, in the core themes of maintenance and asset management in terms of increasing uptime, increasing lifetime of the equipment, taking, the safety measures, all the things that are really important to maintenance and performance get improved. However, I think the one point I would like to strike out is what we see is actually digital is not replacing the maintenance personnel, the asset managers, is rather augmenting them, is rather multiplying them. And you take our solution, Loctite Pulse. We come from Loctite, the adhesives, right? However, making Loctite Pulse, making it an IoT enabled, it's a very nice, symbol for what digital is capable. It augments the expertise that we have, for instance, in sealing parts, in thread locking bolts and nuts. So I think this is exactly the story that with digital, we are not going to replace us all, right? Not the opposite. We will actually take sustainability, take all these things that are important in our space to the next level.
Yeah, that's for sure. So maybe, Peter, you can give some examples on how specific digital technologies are really providing effective, enhancing industrial maintenance practices. Huh?
Yeah, sure, Wim. And like Kourosh already gave a good path to the goal in his explanation. What we are seeing in maintenance landscape and in the broader landscape of asset management is a transition going and taking place, not replacing the workers, not replacing maintenance managers. Instead of, like Kourosh said, and I really like the word, augmenting them. And how do we do that? So a concrete example. What you see is that a lot of companies are struggling nowadays in defining a good maintenance strategy. And let's say traditionally we do break and fix maintenance, so something breaks and we fix it, or we do preventive maintenance where we have time-based maintenance, example given every year or something like that. Now, digitalization has a huge impact on that because we are starting with condition-based maintenance, going into predictive maintenance. And here, Endress and Hauser also is a supplier of, as I said, with instruments as a source of data. So the data that we have out of our instruments enhance this condition-based maintenance. So we can supply maintenance departments with a whole bunch of diagnostics that will help them to better plan their maintenance activities. So instead of doing the maintenance time-based every year or during a shutdown, we can analyze this data and use it really to plan the maintenance much more efficiently. So yes, indeed, it has an enormous impact, and the future looks bright in that sense.
Yeah, well, it makes sense of having condition-based maintenance instead of just preventive or reactive maintenance. What are for you, in fact, the main advantages of having things done condition-based instead of preventive or reactive?
And what I often use also in discussions with colleagues, but also with asset managers of asset owners, is actually not a maintenance KPI, but a production KPI, being overall equipment effectiveness. And if you see overall equipment effectiveness is availability times performance times quality. If you counter that utilization is actually planned downtime. So to your question, how can condition-based maintenance help here? We can significantly reduce the planned downtime. So if we know the conditions of the devices, and here we take one step further, we of course Endress and Hauser as an instrument vendor, as a system provider, brings solutions. So we are looking at our own stuff, but we also have data in these devices that say something about the complete plant. Example given, corrosion, build-up, and all these things. And I think also with the build-up stuff, we go also into the Henkel case, where you guys also measure this and try to predict something. So take this example of build-up. So we measure build-up, we can detect build-up, but we can even predict build-up in plants. So it's not only on the measurement performance, but the whole performance of a plant. So if we can make sure that we have a transparency on what is happening in the plant, and we give this to maintenance operations, they can take adequate decisions on where they need to plan an intervention. And instead of doing regular annual checks, or even if you can go to a food and bev company who is doing cleaning and SIP processes, if we can measure this build-up and we can say, look, we are at this level, so it's time within X time to do a SIP, it's much better than do a SIP every weekend, example given. So it has an immediate impact not only on plant performance, but also on sustainability, because we are losing less products, we have less downtime, etc., etc.
Yeah, of course. And we're going to talk about sustainability also a little bit later here in the podcast. But in the end, it's all about also, eliminating unnecessary stops and as such enhancing performance. It's also about eliminating unnecessary downtime because of unforeseen failures, so that you can really prevent those and continue to work and replace whatever is necessary during a plant shutdown, in fact.
Exactly.
So going a little bit further on this digital transformation, you see, Michael, you see that this digitization is really transforming maintenance, the way maintenance is also performed. So can you elaborate a little bit on how these practices also enhance the efficiency of maintenance operations?
Yeah, happy to do so. So actually, as Kourosh already mentioned, with what we call locked pulse, we, for example, currently offer two main solutions. So one solution is all about detecting critical leakages at critical assets all over in your plant. So let me take a concrete example. One of our customers is Shell with its refineries, where it's actually all about detecting leakages at flanges, at pipes, at tanks. So we have here a solution that helps to identify or to detect these kind of leakages at a very early stage already. And thanks to our actually core products, so the previously analog solutions, we're able to keep that leakage actually within a protected environment, notify the customer so that the customer can react instead of fixing, repairing a solution with high efforts. And that's actually one of our solutions, mainly focusing at all critical assets with leakages, in particular in the hydrocarbon context. And then the second field is all about fittings, in particular steam traps. So here we actually see that one of the most often failing assets of many of the industrial customers in the process industry in particular are actually steam traps, where malfunctions can lead to various outcomes. Actually, more or less the best is that you just lose energy, which is of course already a big impact on both on your costs, but also on sustainability. But even worse, it can also directly impact the performance or the product quality, and might lead even to much higher costs afterwards. So this is actually what we can here, similar to Peter, not just detect, but even predict. So tell a customer when a steam trap in that particular case is starting, showing malfunctions, and close maybe to a blow through or to a stuck closed.
Yeah, okay. And so knowing is enabling to handle and to plan accordingly. So increasing efficiency of maintenance operations as such. So that's very, very interesting. So of course, Peter, you talked about that the sensors of Endress and Hauser hold a lot of data combined with other data. You can apply them in advanced technologies such as artificial intelligence. So can you explain how these technologies can be leveraged to perform routine maintenance tasks?
Yeah, absolutely. Let me give a concrete example. And as you mentioned, instrumentation, our core business bread and butter. A common maintenance practice for instruments is calibration. And there's many debates about calibration. So if you ask to asset owners, why do you calibrate? Often we get the answer because we need to. It's about regulatory requirements, etc., etc. But there's even more behind it. So calibration is done by coincidence out of convenience. So we have shutdowns, we have a yearly shutdown or planned shutdowns, and then this time we do the calibration. So it's really a routine preventive maintenance task at the moment. However, can you imagine that when we collect the process data as well as the measuring data, and then additionally the data from previous calibration activities, so we have more contextual data, and we use artificial intelligence to calculate the next or the best interval for that particular device, then we really go from a routine maintenance operation towards, let's say, a better planned situation. So we plan and we calculate based on data and then also previous calibrations. We calculate efficiency when the next calibration should take place. In the same time, and this makes it even more interesting, I told you before we have some advanced diagnostics in our devices. We call it heartbeat technology. It's a technology that we have developed. In this heartbeat technology, we also have an heartbeat technology verification. So imagine we do the calibrations based on the interval that we calculated. Nevertheless, to increase the confidence of the asset owner, we can run these verifications while production is running. So we don't need to build out the device to execute the calibration. We don't need a shutdown. So we have two items here working together. A calculated based IA, so not on gut feeling, not on experience, but a very scientific way of calculating an interval, plus intermediate checks without interrupting the process. So we are doing this already at the moment, and the results are quite promising. So we, in average, we can extend calibration intervals for 67%. 20% of calibrations we keep as it is, and 13%, that's even more interesting, we need to shorten the cycle. And depending on the industry you are, this 13% shortening the cycle means a risk on reliability, a risk of unplanned shutdowns. And if we can avoid that, this means more than actually the 67% of optimization. So you see here, we go from really, even, sorry for calibration engineers among us, but even a tedious job like calibration, done on a regular basis, done every year, every 6 months, to a high-end scientific approach with condition-based items in it, really impacting the overall plant performance.
Yeah, it's impacting the overall plant performance, but also the performance of those calibration engineers too.
Exactly. And also here, first of all, we have the scarcity of talented people on the market. And let's be honest, a good calibration engineer with good metrological knowledge, his or hers, sorry for that, knowledge can better be used in quality areas. So use the output, use the measurements that you have, and instead of just, again, coming to my question, why do you calibrate? And then often we also get the answer to have this certificate. In my eyes, nothing is further from the truth than that. So if you have a good metrological expert that knows what he's talking about, and he can use the measurement performance, and it's really physics and mathematics, you go and you reduce your gauge curve, so you can make sure that your asset goes better to the targeted set point, and your statistic process control is much, let's say, narrower than we have before. So indeed, it's changing the whole way of working, and you can make a tedious job very interesting and also very exciting for the people.
Yes. Kourosh, that's something that you mentioned also earlier into your intervention. Eh? So it's freeing up time to really address the important issues.
Yeah, thanks a lot, Wim. I wanted actually exactly to tie in here. I think if we, in the end, step back and say, what are we talking about? In the end, we're talking about human beings, right? I think this is really important that we acknowledge that. And you guys are, Wim, you specifically are doing a great job with Industry 5.0. I think is the term that is used here in this context. In the end, is about augmenting, I use again that word, multiplying the knowledge of the experts we have, as maintenance personnel and asset owners, that this is supported by data, that the data is helping the gut feel, the experience of these people to step up, to actually create additional value, right? And there is obviously with the rise of sustainability in every factory of the world, in every plant of the world, this is a very important element that, the whole digital piece is not a thing on its own. It's a mean to improve what we have as capabilities. And let me add perhaps one thing. That's why we called it also Loctite Pulse. Yeah, we humanized it on purpose, the pulse, so that you can sense. Think of you have an application, a flange under insulation in a refinery, like Michael was saying in Shell. Yeah, you want to be sleeping safe, that propane is not leaking and you don't notice it, right? So this is, again, helping with condition monitoring on the one side, that these unplanned situations don't happen. But more important, Peter, as you said it, you can enhance, actually the performance. You can improve the situation that you prescribe in a better way your operations. And that's why, in the end, it is a lot about also transformation. It is about how we get, us being rather well-oiled hands, right? To actually use things like, AI, as Peter was saying, right?
Yeah, it's in the end, it's all about making better informed decisions.
Yes, exactly.
Yeah. Okay. So, Peter, you talked about these sensors. Nowadays, we also talk about the Internet of Things. So how can the data collected from these IoT devices be utilized to optimize the maintenance processes?
Yeah, that's for me, that's the $1 million question, Wim. But I first would like to comment also to Kourosh's explanation about pulse and humanizing it. What a coincidence. You call it pulse and we call it heartbeat technology. So let's take heartbeat technology to measure your pulse, by the way, Kourosh.
Great minds.
So great minds think alike.
Right? Like you guys say in Belgium, le grand esprit se rencontre.
Yeah, I really like it. Now, Wim, your question, the $1 million question, and I hope you don't mind. I'm going back again to overall equipment effectiveness, availability times performance times quality. So, how your question indeed? How can this Internet of Things devices, the data collected, how can this be used to optimize maintenance processes? And then again, take again availability, performance, quality. If you take availability, we want to use the data to reduce the unplanned downtime. Now, how can we do that? Because that's easily said. Yes, of course, we use data and we reduce unplanned downtime. Now, imagine there's a failure. Failure occurs, and it doesn't matter if it's on our devices or, like Kourosh and Michael said, on a propane leakages. That doesn't matter at all. There's a failure that occurs. So if we use the data correctly, can you imagine that the asset or even the leakage system or our detection that we are having automatically triggers a work order in a computerized management system? And this, so the work order is directed to the failure of the asset, but also we use the data to include cause and remedy data. So if it is a leakage, if it's something on our devices, because we have the data in these assets on themselves, we should also have cause and remedy items in it. So the device triggers a work order in the CMMS, but in the CMMS also the cause and the remedy are included. So the maintenance operator that needs to fix this issue immediately goes immediately to this information, grabs the things he needed, instead of going first to the assets, looking what's going on, walking back to the office, pulling out binders, trying to find some issues. We use the data at hand that we can supply to the guy or girl in front of the device, and they can immediately take the correct actions. And even what we also do, we enhance this with knowledge articles. Probably, in all likelihood, this failure did already occur in another plant with another asset owner. We already have not only cause and remedies, but we also have knowledge articles, how other people were able to solve the issue. So we provide these knowledge articles towards the maintenance operator. So that's only about availability. If we then look actually to performance, again, this will rise the performance by using data. And again, how we do that? Because we measure the performance at the moment, and we do not only condition-based maintenance, we measure the performance at the moment, and we see there's a certain performance decrease. So also by using the data well in advance, we can say to the operators, to maintenance, people, please be careful, in X time you will have an event. So instead of waiting for a failure to occur, we use the data out of the devices with previous experiences, and we can help them to plan better their maintenance. And I can go on, Wim. I have many examples like that. And you see here, it's always a combination of catching two birds with a stone. So for me, it's a no-brainer. If you use the data that you have in a proper way, in the proper environment, you absolutely can increase the maintenance processes, their efficiency, certainly.
Yeah, well, talking about processes efficiency, Michael, we know that remote monitoring, predictive maintenance, these algorithms are becoming more and more prevalent. So we see them everywhere coming up, and so can you also elaborate a little bit further on how this really can increase efficiency of maintenance operations and also help in addressing the issue we all know of skill shortages?
Yeah, actually, predictive maintenance and same as remote monitoring in the end help us to achieve two goals at once, minimum two goals at once. One is, and we talked a lot about that today already, is efficiency and effectiveness, be it by enriching information, be it by simplifying processes, be it by accelerating processes, or maybe by getting rid of certain, in particular, very obsolete or very, very redundant processes completely. So this is all paying into efficiency. And at the same time, by being more efficient, you need less resources. So it helps you at the same time to a certain extent to also solve the skill shortage. But that's only one dimension of it. Another dimension is that you can, with the help of digitalization, and both Peter as well as Kourosh mentioned it several times with the term augmenting. By augmenting personnel, you can actually enable less qualified or just less experienced personnel to conduct the same processes or more processes actually at a higher quality or at an earlier stage with less human support. So this is definitely another dimension, and where actually predictive maintenance or also, of course, remote services can help a lot. Remote services in particular also help centralizing certain resources. So maybe you do not need all the experts anymore in each of your sites or in each part of your site, but you can more centralize that at one point and then connect more or less on demand your workers on site to the ones who have really all that experience. So that's maybe the remote part. To be honest, my personal opinion, even better, it's less the remote guy who gets connected to your person on the ground, but it's maybe even digitally enabled, digitally supported, so that maybe even an algorithm, a system, just tells you what exactly to do. And I think very important to also stress, and this is maybe a short anecdote I would like to share here with you, is that also sometimes the soft benefits of digitalization that we might not directly see when talking about it, that in the end are also very critical. One reason why we have that skill shortage is not because there's nobody out there anymore, but it's actually a lot of young people not wanting to do that job anymore, not wanting to walk around with a screwdriver, and maybe the image of industrial maintenance is just not what they are striving for. And I think here digitalization can really play a key role in making such a job much more attractive. And that's exactly what recently one of our maintenance managers told me, who said, yes, it's all nice to have these smart maintenance solutions. And yes, it also helps me improving my processes. But to be honest, one of the main reasons why he is going that direction is he wants to make the job more attractive for the Gen Z, or whatever you call it, the young guys and girls out there who might look for a more digital, more modern, more whatever job, where really digitalization can help us a lot. So that's maybe the more hidden benefits of digitalization that we sometimes do not really have first of all in front of our eyes.
Yeah. Can you elaborate on that a little bit, Peter? Do you agree with this analysis?
To say it in a double negative, I couldn't disagree less. So I'm more than 100% agreeing to it. Absolutely, and we see this in the daily practice. And I like the example also with the young engineers and the vision about the screwdrivers versus the new generation. To give an example, I remember one of my first tasks when I came out of university, that I needed to commissioning a PNID controller. And as a fresh university guy, used to build algorithms and calculations and computers. I went into the maintenance shop and I asked to the old guy, hey, where's my computer? And he almost slapped me in the head, gave me a screwdriver and said, go, because the PNID controller that I needed commissioning was a pneumatic controller. But these are long gone. So also here we see that making it more attractive for the young generation to come in and giving them the tools that I use to handle with tablets, phones, visual glasses, things like that, is really enhancing these practices. And we are doing it in the practice already. So with this visual support, applying remote services, what we achieve is that we can take a senior experienced guy, put him in an office environment, and let a junior guy or even an asset owner technician on site with less experience being guided with visual support. The most easygoing that we see is either with tablets or with phones. Also, even in the process industry with intrinsically safe, so AX devices, we can make a remote connectivity towards the worker on site. The experienced engineer in the office is guiding him, is helping him. So the junior on site will learn from this experience and will learn from the experienced guy. But also here we not only let's say help the young generation, we also help the experienced generation, because previously, certainly in our environment, and I don't know Michael Kourosh how it is in your environment, but with us, the career path of a service engineer was typically either moving towards sales or marketing or do something else, or maybe become a service manager. But that is not everybody his dream job. That's not everybody his skill set. And they have so much experience, these guys. So what we really do is we take these guys and we are not getting younger ourselves. Last week I also climbed some tanks of 40-meter heights with a young engineer, and I saw absolutely the difference. So he did 5 more than I did. So the better is that we take these experienced guys, put them in a nice environment where they can support the young guys, and even out of the home office. We are literally doing this at the moment, that the experienced guys are sitting in the home office, connects to the young guy on site, and helping that. And then the last really nice side effect of this, can you imagine how many hours of travel time we reduce with this? So even the sustainability and the CO2 emissions goal is also hardly reached with this area. So I think here digitalization absolutely is a key, and I think we're just starting it. We are just starting it. The road in front of us will be, in my eyes, fantastic.
Yeah, and so digitization is offering a new way of working, a new way of performing this maintenance and service, but is also offering new career opportunities.
Yeah, for sure. Like I just said, the instead of the experienced service engineer becoming a sales guy or a service manager, he can even increase his experience, his knowledge, and he can do other stuff. But also, so that's one side of it. The other side of it is also that for having these tools, for having this digitalization, this visualization, and like Michael said, having also an intelligence behind, a calculation behind, an algorithm behind, you need to have totally different skill sets. So it's not, and that's why I brought in the joke with my pneumatic P&ID controller. It's not the guy with the screwdriver anymore that goes into the field and turns some screws and makes things better. We really have now an outflow. There are even end studies in mathematics, physics, engineering, data, computer science, and algorithms. So yes, these guys are often looking at artificial intelligence on a different perspective of process improvements, but we can use these same skill sets to actually apply this on maintenance and asset management and make the experienced guy who's sitting in the home office capture his knowledge in the algorithm that we then can use also to supply with others. So you see, it's a totally new career opportunities, which for the young generation is going to be a blast.
Yeah, the same thing goes at Henkel.
Yeah, exactly. I think we have all an obligation here. We need to attract more, people towards what is at our heart, right? Maintaining and running assets in a very sustainable way. With what is happening out there with the sustainability trend towards circular economy, it is of utmost importance that we activate many, many, many more, young generations, but also older generations to come and do the maintenance work. It is, there is a massive shortage. And I think it's up to us to translate the opportunities that, for instance, digital is offering into something that is a very tangible benefit for these people. Yeah, it's a way to do something purposeful. If you think of the contribution maintenance can offer by extending the lifetime of an equipment by 30%, applying, for instance, a few drops of Loctite, this is like, then, it's like planting a lot of trees, right? Just to put things into perspective. So that's why we spend a lot of time in training on site. So we train per year as Loctite, like 200,000 maintenance workers on site in their plants. And part of that training is becoming now also training them in IoT, using Loctite Pulse, so that in a very tangible way, we help them to see, hey, this is like helping you, right? It's not replacing you, it's just helping you. And I think that's part of the exercise to get the innovation into a very, let's say, positive experience to them. And then also thanks to your organization, we can spread the good news to the world, right?
Yeah, and sustainability is a big point of attention nowadays, Michael. So, in your opinion, how can digitization help to contribute to more sustainable practices?
Yes, so there are actually many dimensions, and I think a lot of the topics we already addressed, so I'll keep that part really short. But it's again, I don't want to repeat here too much, but it's again efficiency, effectiveness that, of course, also, if you improve that, also has a positive impact on sustainability. So less waste, less actually resources required. It's also about energy waste that you can reduce. So that's what I earlier mentioned. If you identify the not well working assets at an early stage, you can actually save a lot of energy, which, at least depending on how the energy has been created, in most of the cases comes with CO2 reductions actually, or less CO2 emissions. So that's I think the more obvious part of sustainability. Maybe a little less obvious is I talked a lot about leakage monitoring. It's also the aspect of emissions, so avoiding certain emissions going beyond just CO2, but also be it various kinds of hydrocarbons. You don't want to know how many tons each and every refinery actually emits every year, just on average. So that these are numbers that are really frightening, and at the same time avoidable with smart solutions. So with having sensors at hidden flanges, at tanks, at whatever. So that's I think the more obvious part. Where also digitalization can help addressing sustainability is by making all of that transparent. So what we realized is that yes, a lot of maintenance managers and even more manufacturing managers have targets now to achieve certain sustainability goals, be it reducing CO2 emissions like all our colleagues, at least at Henkel plants, do, but also be it reducing energy consumption and so on. But what they usually lack is the real information about that. And with the digital solutions, with sensors at the assets, not just with theoretical calculations, you can really make much more enriched or data-based in the end decisions and actually create that information. So that's why actually our solution, like to take just the example of the steam trap monitoring I mentioned earlier, provides to the end user a direct information of how much energy did I lose, how much cost did that create, but also what's the CO2 emission linked to that, so that I have it really at my fingertips, the critical numbers, and of course then even better to later centralize all those numbers and take a more informed decision.
Yeah, so digitization really allows to make more tangible the added value of maintenance operations in preventing leakages and other sources of energy waste.
Exactly.
Yeah, okay, perfect. So, Peter, do you have also some examples, some further examples on how sustainability practices really can be pursued through more digitization?
Yes, absolutely. And to let's say to build on Michael's story and even to comprehend what we currently are doing is example given the EU emission trade schemes. And so like Michael mentioned, asset owners are obliged to report their CO2 emissions. But also they are required to have a maintenance plan for that. So the trading scheme also dictates you need to maintain your assets properly. And I mentioned before that we have this heartbeat technology where we can actually have diagnostics and information inside the device itself. So this heartbeat verification that we can do for certain measurements is also accredited by an external body, by the TÜV in Germany. So that means when asset owners want to apply to the EU trading schemes, and if they apply the heartbeat verification that we have in the smart meterings, they already have an accredited proof that's even, let's say, exceeding what the EU trading schemes are saying. So here we also use this digitalization practices with direct impact on this ETS. Additionally, and again, Michael, I think we need to sit together because we are sadly comprehensive on this side. I mentioned earlier before the build-up detection. So what we also see with asset owners is that by detecting and even predicting the build-up, that you not only reduce energy, because when you have a pipe or an installation that is clogging, the pumps, and you have more energy usage because due to the clogging, the pumps need to work harder to get the fluids through the pipes. Again, also, I mentioned the example of CIP. So by having clogged installations in certain industries, they do a lot of CIPs, maybe too much. So we detect the level of the clogging, and depending on the clogging on the buildup that is in the installation, we can advise when it's really time to launch a CIP and not just do it, example given, every weekend. So you see here that by measuring, and not only by measuring, but also using the information that you have at hand and apply it to the application that you're working upon, you can really help also to have asset owners reaching their sustainability goals.
Yeah, oh, sure. So, well, we have done a nice travel through the world of industrial maintenance and transition. We've been talking about how this digitization is impacting the way we do maintenance, how it can improve efficiency, how it's affecting our workforce, how it's affecting sustainability. So maybe you might have some final remarks, Kourosh.
Yeah, sometimes you need to dream, right? And, imagine a world where every drop of Loctite or chemistry becomes intelligent. So I think we together took the first step of the IoT revolution with the rotating equipments. And with Loctite Pulse, what we're trying to do actually is also sensorize the static equipment, right? And we have made some good progress there. So our dream is if we can really come up with additional solutions around smart chemistry, then you can even think of substantial added value for society. So that's part of our dream. And perhaps, Michel, you want to tie in here?
Yeah, exactly. Just maybe to briefly elaborate what we mean by that. So by smart chemistry, the idea or the dream is actually to completely get rid of sensors, or in other words, to more or less sensorize everything. So you find, for example, our functional coatings in many critical applications. Imagine those become sensors themselves, tell us about certain status, be it of the asset, be it of itself, be it of the process they are linked to. So that's without now going too far into the detail here, as you can imagine, there is a lot of confidential aspects in there, but this is actually what we are striving for. So that's like the vision Loctite or Henkel with its data-enabled solutions is striving for.
Yeah, I have the feeling that there are a lot of to follow here, and so is Endress and Hauser also working on so new innovations? How in which direction are you moving?
Yeah, I think the recording of this podcast will not have long enough to tell you what we are doing at the moment, Wim. But anyway, indeed, like Michael said, there are some quite confidential stuff that we are doing. But nevertheless, we are really in the transition also as a company. As said in my introduction, our bread and butter is still the devices, still the instruments. Nevertheless, we also see that the market is the market in general. The way asset owners, manufacturing sites are coping with the daily dilemmas that you mentioned, sustainability, scarce resources, all this kind of stuff, is also forcing us to completely rethink how our bread and butter, being instruments, can actually sustain, help, and help our customers to reach their overall goals. So we are really looking beyond having a flow measurement or temperature measurement or pressure device. Is what is the application? What is this asset owner doing? and how is because to take it in one sentence, and what I often use also with my colleagues, our sensors, our instruments are touching on a continuously based. It's not even microseconds. It's continuously. We are touching the products of the asset owners, what they are produced. So we have so much data and so much wealth in our devices that we are not even aware of ourselves what the asset owner can do with that. So we have many things going on, Wim, and indeed, let's say the basic things, condition-based maintenance programs, evolving to predictive maintenance programs, evolving also to prescriptive, evolving to planned performance optimizations. To give you one example that we are working on, and also to put some flesh on the bone, we are working on a thing that we call measurement plausibility. And again, using the word data, how often that you see now and I don't want to blame the young generation, don't get me wrong, but we used to have very experienced operators in the plant. They literally, they didn't need to have a SCADA screen. They knew what was going on in the plant. Nowadays, we have the young generation coming in. The plant is already at a certain level, and I quote here a guy from an asset owner. I will not mention the name, but he said, we in the past built from a normal car a Formula 1 car. So the reactor we are having is at this moment so high performance, it's a Formula 1 car, it's not a regular street car. However, the drivers that we put in front of the wheel, they cannot even ride a bicycle. And that's maybe a very provocative statement, but here then we have we learned and listened from that. What we are now doing is this measurement plausibility, is that we use IA, we use the data, and when a certain value is on the operator screen, we can give a coefficient to that value. How plausible is it? Is this really what you see out in the field? Is this really true? So giving the bicycle rider, sorry for the word, giving him the ability by tools to very quickly turn him into a Formula 1 driver. And these are things, this goes beyond the flow measurement, you can imagine. So again, like I said before, I'm quite enthusiastic what is going on in the world. I think there are many, many opportunities, and for sure the use of technology as a means to a goal. And I think this is really important. In the past, we did a lot of technology developments for the means of the technology development. We wanted to prove that we could do this stuff. I think nowadays the change is really, what are the goals? What we really want to achieve? Like Kourosh is saying, take one step back. What is it we want to do? How are we going to do it? And how can we, as a system provider, support the asset owners in reaching their goals? And I think this is key.
Yes, well, final reaction, Kourosh?
No, I think the image that was used is exactly it, right? From make the bicycle driver become fast and Formula E car driver. That's exactly what we all are up to.
Yes, well, with these wise words, thank you very much, gentlemen. Thank you very much, Kourosh. Thank you very much, Peter. Thank you very much, Michael, for this exciting insight in the world of asset performance. See you at the next podcast. Bye.